Okay, so let us look at the program to copy, say, n bytes from a read-only memory, that is a RAM, to the read-write memory, that can be a RAM memory, for the ARM, the 32-bit architecture. So we are going to use the keil AMDK. So let us create the project. Uh, Let us go to project, new migration project. Okay. So we'll always consider creating a new project in new folder. So I'm calling this lab folder, which is there on my desktop, as my parent folder. So I will create a new folder under the lab directory. Let us give it some relevant name. The program 06, the sequential name. We'll open this folder, program 06. We'll save our project as again program 06. It can be any name. Here, just to be consistent, I'm using program 06. You can give any other name also. Let's save it. Once we save it, it will ask us to select the target device. So our target device can be taken from the legacy device database. That is the second option over there. And then we have to search for ARM. So in search window type ARM and let us select a 32-bit version and a little Indian orientation of the memory. So click OK. We get our on the left hand side, we are getting the project explorer. Right now under source group 1 nothing is there, so we'll add a source file which should be having the .asm extension as we are writing the assembly code. Let us create a blank document. We'll save this to a blank text editor with the .asm extension. Please ensure that you are saving in the correct path. So now it should go to the desktop / lab, and our new parent directory is the program 06. While saving, ensure that you save this file or source file with the .asm extension. Name of the file can be anything. See, I'm using the same name as the project name. It may not be same. The importance is the file name should end with the .asm extension. Once you do that, click on save. Now we have to add this source file to the source one. So right click, add existing file. Let's select that file. Before that, I hope you remember you have to select your file type as the ASM source file. Okay, and select that file from the correct folder. Okay, so this is the program 6 folder from my desktop / lab directory only. So always verify that you are selecting the corresponding files from the appropriate folder. Click on add. So file will get added to source group 1. Okay, and we'll write a program over here. So let me copy for the sake of simplicity here. So we'll understand the code here. So basically, as I had discussed before, also that your code should follow certain structure. Okay. So we are going to define a code segment over here, which need to be say read only. Okay. So code segments are to be read only. Okay. Next, this is the label which we are giving to this particular segment. Another very common mistake or the requirement basically over here is this area keyword should start from at least one space from the beginning. So I usually prefer to give some tabs so it makes it look a little bit easier to read. Similarly, end directory should not start from the beginning of the line. These are the syntaxes which have been employed by the, the designers of this IDE. Labels are usually should be touching the first character space over there. So labels should not start from the arbitrary space over there. So these rules we need to follow while writing the program. So here I'm going to transfer data from a read-only memory. So this entire program segment is going to be there inside our ROM. So basically, our instructions are stored in the ROM, your applications are stored in the ROM, so that your application will not get altered accidentally. So whatever is there inside this particular block is a read-only. That particular memory is going to have the only read access. So how to create an array? So we are creating a array over here, array of 5 bytes here. I'm assuming that n, or the number of the length of the array, is 5, and the type of the array is the byte type. So we can create an array. We can specify any name or any label to that particular array, and this is the keyword declared code byte. So DCB is going to be used to define a array, and the value in this array are basically saved one after another, separated by the comma. So you can create any length array. Here I am restricting it to the 5 byte array. Okay, if you want a 32-bit data to be stored, then you can write DCW, that is defined code word. In that case, your data can be a 32-bit number. Okay, like that. Okay, so let us not make it more complicated. We will consider a simple byte type array. So to our intention is to copy this contents 1 2 3 4 5, where we'll call this as a source array in our ROM, to the destination array, which will be there in the RAM. So that destination location here I'm assuming to be 4000, that is 4 and 7 zeros over there. So being a 32-bit processor, address space is also a 32-bit, and we can basically interface 4 gigabyte of memory over there. Okay, 32-bit address space, right? So I'm assuming my source array is starting from this particular label. Okay, it has been stored in the ROM section, and our destination array, we are going to assume it to be starting from, say, this particular value. So I have to copy from here to say 40,001, 40,001, 2, 3, and 4. Right? So I'm to use two pointers here. One is can be my R0. So as soon as I initialize R0 with the address of this particular array, to do that we can use this specialized instruction called as a ADR. Okay, so ADR will make R0 point to the starting address of this particular byte array. Okay, so R0 will capture the starting address over there, and then we can use R0 as a pointer. So this is basically a pointer initialization. Okay. Similarly, R1 can be initialized to the constant value like that. Okay, so both the pointers are now pointing to the starting of the arrays. One is the source, other is the destination array, and I can basically loop this with the help of some a do while loop or a while loop. So here we are storing the loop count value in the R2 register. So I'm assuming that there will be 5 byte to be transferred. Okay. So this is our basic loop here, where we are reading contents of memory location pointed by R0 into R3. Okay. After that, okay, we are going to increment the pointer R0. So this particular instruction is also called as the post indexed addressing, where the pointer R0 is going to be incremented after the data is getting transferred by what value? By value 1. This is a combination of two instructions. Okay. So first, the contents of memory location pointed by R0. So square brackets indicates the pointer. Contents of memory location pointed by R0, which is initially it is 01. Its value will be copied into R3, which is my temporary register. After that, after data is transferred, then R0, okay, which is my pointer, will be incremented by value 01, so that the R0 will start pointing. So once we have accessed or extracted our first information, then our pointer will shift down to the next value, right? So R0 will start pointing to 0 to here. Okay. So we have our first element of the array in R3. That value we are going to store into some another location which is getting pointed by R1. So similar stuff happening here, but instead of load, we are using now store byte instruction, where contents of register R3 will be stored to a memory location pointed by R1. Okay. And then after data is transferred, your R1 will also get incremented by value 1. Whatever value you specify over here, this is basically used to increment your pointer. After that, because our one element transfer is completed, right? The transfer contains from pointed by R0 to R1, and this can be reflected by decrementing our loop counter. So we are decrementing loop counter in R2 by value 1. Then we are checking whether that loop count is 0 or not. If it is not, so if loop count is not equal to 0, then we'll branch to label up. That is, we'll iterate this process again and again until R2 ka value becomes 0. Okay. So this loop will get executed 5 number of times. As soon as R2 becomes 0, this conditional branch will be false. That is, not equal condition, not equal to 0 conditions will be not satisfied and will come out of the loop, where after that we'll get stuck over this here branch here instruction, which is basically a infinite loop or equivalent to a halt instruction. Okay. This will also ensure, this particular here branch here instruction will also ensure that our code will not overflow into this particular kind of a constant data field. So our data will not get misinterpreted as some random instructions. So let us see how to execute this program, and while execution we see some integrate details that how to access a memory like which is 40,000 H, and how to check its value. So let us build target. So before building, we will go to target, options for target, go to output and enable the text creation option, and then you have to build a target. So you should get 0 errors and 0 warnings. So once you have 0 errors and 0 warnings, then only we can debug the code. Start the debug session. Click on OK. That is the evaluation mode warning. That is fine with us. So let us look at various sections here. Central one is our assembly code. Top one is our disassembly code. Okay. So from disassembly code, one thing I want to notice first is the actual location where our array is getting stored, source array is getting stored. Right? For branch instruction, okay, this branch instruction is basically at address 1C, and below that, if you can notice, at address 20, okay, over there our data basically this 0 1 2 3 4, and below that you can see there is 5. These are our 5 bytes which have been stored. Okay. And here disassembler is also understanding them as some it eventually finds out that that particular pattern, the data itself is corresponding to some instruction, which is a misinterpretation of that data, but we are not worried because our program will get stopped here. The intention over here is, if I want to browse this particular contains as a memory map, then we are having another option over here. So on this particular bottom right hand side, we have to click on memory window, because we need to check now whether data is being transferred from some source to some other destination. So I will kind of maximize it. So we'll drag this and we'll place it on this particular small arrow over here, so that it will get kind of maximized and we'll be able to browse it easily. So in this memory window, let us see the contents of memory location 20H, right? So we'll type here in the address section, we are going to type here 0x20, hit enter. Okay. And then we are able to see the contents of this memory location. So here basically at address 20H, value 1 have been stored. Like that, the next byte or the next address is 21H, where value 2 is stored. Next location is 23, I'm sorry, 20, 21, 22, 23 and 24. Okay. So this only is showing here on the left hand side, it is showing the address of the starting byte itself. okay, to organize or to make things more simpler to read. Okay, so basically this is how we can observe the contents of memory. So let us see what is there at memory location 40,000, whatever this value is there. So I'll copy this address, paste in the address field, and let's see what is there at this location. So you can see basically nothing is there. That memory has a value 0. So our intention is whatever is there from this particular location, which was basically 20H, right? That contained that value 1, 2, 3, 4, 5. Basically, I want to store into a memory block starting from 40,000 H over there. So let's see how to do that. We have already written the program for that. We'll see the execution. Let us execute and see what happens. So there is a particular error which is going to happen here, which we are going to notice. The error is currently by default entire memory, including your code section and this particular 4 and 7 giga, this particular memory is having only a read access. Okay, so if memory is having a read access, we cannot write to it. Okay, so let's see what is happening over there. So we'll execute the program instruction by instruction. So currently instruction ADR is there to be executed. We step into it. Okay, so you can see R0 is pointing to the starting address of that source block, which we have manually also find out that it was 20H, right? So this particular label is basically nothing but the address of our byte array over here, which is getting copied into R0. Like that, R1 will be initialized with value 4 and zeros, all those zeros, right? Next, our count register will get initialized with value 5, which is R2. And now we will start reading contents from memory location pointed by R0. Okay, we'll take it into R3. So contents of memory location R0, memory location pointed by R0 will be whatever is there at location 20H, right? So which is nothing but value 1. Okay, this value is going to be copied into R3. So two things will happen when I execute this instruction. Okay, so this is a combination of two instructions. One is contents of memory location pointed by R0 will be copied into R3, and after that your R0 will be incremented by 1. So current value of R0 is 20, that will become 21, so that we will be ready for the next iteration. Okay, so let us observe this. We will execute this, and I hope you can see that the contents of R3 is now 1, and also R0 is 21. Okay, so R0 have shifted to the next address, and contents of that memory location, earlier memory location was 20, that have been copied into R3. Okay, let us look at this store instruction now. Similar things should happen. So contents of R3 now will get stored to memory location pointed by R1. R1 is pointing to this value 44 and all zeros. Let's see what happens here. So I will paste the address over there, and let's see whether we are able to now copy the contents or store the contents of R3 at location R1. Okay, so here this error is going to happen. Let me execute and demonstrate. So as soon as I execute, okay, nothing is happening first of all on the memory, and we need to observe this error. So it is throwing the access violation error that memory location do not have a memory write permission. Okay, so this permission has to be granted if I want to modify particular memory, and let us see how to do that. Okay, so basically this memory write is going to be ignored if there is no write permission over there. So let us see how to provide a remedy for that. So I want to execute the program once again. For that I will reset this. Okay, so RST or a reset, and now we will give the appropriate permission to that memory location. That permission is given with the help of a command called as a memory map command. Okay, so this is the map command, which tells okay, the keyword is map, which tells from starting address say 4 and these many zeros till ending address 4004. Okay, these are the 5 locations, right? 4000, then 1, 2, 3, and 4. Like that, 5 locations are there. All those 5 locations will be getting the read, write, and execute access. Okay, so here we wanted okay, both the read and write access. I have also provided the execute access. Okay. So this command we are supposed to okay, provide give it to the simulator in the command window. So below okay, this is the arrow key, this particular greater than symbol, that is your command window where you are supposed to paste this command, okay, map command, and as soon as I give this command, what will happen is the permission to this particular memory is going to be changed. Now let us execute the program once again, okay, with the updated permissions, and okay, you will see that as soon as I execute the store instruction, the value 1 will get written over here, which is nothing but okay, the value which we have read from the source location. So now our okay, memory location 1 to, that is 4000 and 1 to 4000, 1, 2, 3, and 4. These 4 locations have been granted the access to read, write, and execute. Okay. So if you continue like that, and you will see that one by one the data will be getting copied from the source pointer to the destination pointer, and as soon as all 5 bytes have been transferred, our branch instruction will tell that loop have been completed. Okay, that is here R2 have become 0. So R2 if not equal to 0, then only we are moving up, that particular condition will be failed. So we will exit that loop and we will come back to this, we come down to this here branch here, which will get now continuously executed in the infinite fashion. Okay. So this is one way in which we can provide the transfer the content from one block to another. And the key thing to be noticed over here is that how to provide the permission to, or the right permission to various memory locations, and how to tackle this particular access violation error. Okay, so just for sake of completeness, let us try to copy further this particular data from some location. So let us say right now we have this data at 40H, or 4 and all zeros. I want to transfer it from 4000 to some another RAM location 80,000. Okay, so the code for that, let's see, for sake of completeness, I will copy it over here. So first part is same thing. Okay, so I have added few more lines okay beside the first part, that is below that. I'm now copying the, till here we have say already loaded the contents of our okay read-only memory to location 40,000 and above, right? So from there I want to now so this block will become my source now, and from there I want to transfer it to some another block, say 8000. Okay, and here we'll consider both of them are RAM. Okay? So both of them should be given the permission to read as well as write, and the code looks like this here. Now R0 is going to act as our source pointer, so I'm initializing it to 4000 and all zeros, like that. R1 is initialized to the destination, starting address of the destination array is 8 and all 7 zeros. Again we have to reload the count, loop count, because it had been died to 0 previous iteration. We have to reinitialize here, so please make note of it. Another thing to be noted is we cannot have the multiple labels with the same name, so I cannot replicate here up and up, so I have to create a separate label. Okay, otherwise okay our compiler will throw the error, or sometimes it might create a logical error that from here you might move to this particular location while your intention was that is, if you use a label up over here, then instead of your compiler will not come to know where exactly to go, right? It will not understand that this loop is started here, so you should go here. No, if your instruction says go to label up, it instead go to this particular path only, right? So here compiler will not throw the error, but that is the logical error. Yeah? If I instead of writing up one, if I write here only up, then that is a logical error. Okay? So yeah, create the labels meticulously over there, and the remaining code is quite similar. That is now we are calculating the loop to transfer the contents pointed by R0, taking it into temporary register, and then dumping it on the memory location pointed by R1. Okay, so that is the entire code. We will build the target. So let us see the execution. So we'll go to the debug, starts our debug session, click OK. Yeah, so I will execute the code, okay, till we get all five bytes at address 48. Okay. So again, as I mentioned earlier, we need to provide the permission to read and write to the appropriate location. So along with 40 to 4004, we also have to now give similar permission to the 80,000 array also. So I will copy this command, the map command, one by one, and this need to be given into the command prompt. So like that you can basically the point I'm trying to emphasize here is multiple locations can be, or multiple blocks can be given a specific uh, privilege to become a read-write type memory, right? So this has to be done beforehand before the program is executed, so that write violation errors can be eliminated. So here, if I execute, first we are reading from the ROM. Okay, that was our default of the code segment to the 40,000 location, and as soon as I exit that loop, okay, as soon as we exit the up loop, okay, this particular loop, okay, which is copying from our initial array. Okay. Now we have come to the second up one loop. Okay. So here again pointers will get reinitialized, and let me just change this address to 80,000 like that, and let's see whether our code works satisfactorily. So again, same thing, we'll execute it, and I hope you can see that now there is no error, and we are able to copy contents from one block to another block. Okay. So the takeaway from this exercise is, you can create the data structures. For example, if you have been asked to perform some operations, read as well as write operation on particular array of a data, then if specific permissions has to be given, this will come handy while performing, say, sorting the array. So if we are performing the sorting array operation, then that particular block has to be read as well as modified, right? So the sorting, the block of memory which you are allocating for where you are saving your array to be sorted has to be given a write permission, read as well as write permission. Okay? So that is the overall picture. Another thing which I would like to emphasize here is it is always a good idea to save this particular map locations into a map file or a INI file, so that it becomes easier while debugging, and you don't have to do the command again and again, right? So this is the shorthand way. For that, what you have to do is you have to go to your project, go to this particular program folder, create a file with the extension INI. So currently you can see if I create, I can use any text editor for that matter of fact. So here I am going to create a file with the extension INI, but my extensions are not visible. By default, this should get a text extension, txt extension, which is not visible. So how to enable it, I hope most of you may be knowing, but let us see how to do that. Go to the view tab over here. In case of Windows, view, click on this option, change folder and search options, and then you will get this dialog box. Go to view tab, And if you go a little below, you'll see there is this option enabled file extension for the known time. As soon as I remove it and click on apply, you can see that the extensions of this file types will be visible. So important, why this is important? Because I need to create a file with the extension .ini, right? So in this particular folder, we'll create a file, let us say my memory map. The name can be anything, okay? .ini. Okay, this ini extension is important. Name of the file can be anything, okay, you want. So you can save this file, click on yes that you want to rename it, okay, and inside this file, okay, you need to store your map command, so I can edit it with any standard, okay, editor, and our map commands can be basically copied into that ini file. We'll save it, okay. So okay, basically both the map commands are there in our .ini file, and we need to now instruct our compiler, our assembler, to take those map command while performing the linking operation. So to do that, you have to click on the target one, right click on target one, options for target one. Okay, then you have to go to the debugger, okay, debug option. In the debug option, while performing the debug, you have to use that ini file. So click on this particular field here, and basically you have to select that .ini file. Okay, as simple as that. Now you don't have to do this command again and again while debugging. Okay, click on OK, build target, and now you are basically good to go. Okay, so basically when you debug, it automatically loads those commands, and you don't have to give them explicitly. Yeah? So memory will be configured beforehand. Okay, very important that whenever you are going to create a structures, data structures which need to have a write permission, you can give them this permission with the help of the map command. This is the takeaway from this exercise. Okay. So thank you very much for looking at this.